Now we are taking the second application of the Gauss law, that is electric field due to infinite plane sheet of the charge. Here we have considered this as a plane sheet. This plane sheet is having the positive charge and it is infinite in extent. We have considered sigma as the surface charge density of this plane sheet. ये शीट का फ्रंट वाला पार्ट है और हम लोगों ने दो पॉइंट्स कंसीडर किए हैं, पी डैश और पी. फॉर एग्जांपल ये एक हमारे पास ऐसे ये शीट, क्योंकि 2 डायमेंशनल बोर्ड है, शीट ऐसे है, एक पॉइंट पी शीट के सामने है और आउट ऑफ सिमेट्री सेम डिस्टेंस पे पी डैश पॉइंट दूसरी साइड है. तो यहाँ पर हम लोग क्या करेंगे, एक गॉसियन सरफेस सिलेंडर ड्रॉ करेंगे जिसमें एक प्लेन जो हमारी सरफेस है उस पर हमारा पॉइंट पी आ जाए और उस गॉसियन सिलेंडर के दूसरे प्लेन सरफेस पर हमारा पॉइंट पी डैश आ जाए. तो दिस इज अ सिलेंडर हैविंग एरिया ए. प्लेन सरफेस का एरिया ए है. अब हम देखते हैं कि ये जो हमने सिलेंडर कंसीडर किया है गॉसियन सरफेस का, यहाँ पर हम इलेक्ट्रिक फील्ड इंटेंसिटी जो है दैट इज ई. लेट ई इज द इलेक्ट्रिक फील्ड इंटेंसिटी. This electric field intensity is uniform throughout. Now there are three phases. This is the first phase, this is the second one, and this is the curved surface of this cylinder. Now if we consider the curved surface and say any small area element dA within this, this is the direction. And what about the electric field? Electric field is in this direction or on the other side this direction. Since electric field is perpendicular to this, if we consider the plane surface and in that we have considered a small element area dA, the electric field and the area are in the same direction. Similarly, outward direction, because the positive charge, so electric field, and if we have considered a small element area dA, electric field and the area element will be in the same direction. So we are having the three surfaces again on this cylinder. One is the curved surface and two are the plane surfaces. So let us find out the electric flux because of these 3 points of the surface of this Gaussian cylinder. Now consider Gaussian cylinder. Now the electric flux due to plane ends of cylinder is equal to E dot dA for first plane surface and E dot dA for the second plane surface. The dot product of electric field and the area element both are pointing in the same direction, so cos 0, and that will be E dA cos 0 plus E dA cos 0. Electric field intensity is constant throughout for the plane sheet, therefore E can be taken outside. Cos 0 is 1. So total integration of the area element, and this comes out to be EA plus EA, it is equal to 2EA. Mark it as equation number 1. So the flux is equal to twice of electric field into the area element because of these two plane surfaces. If we consider the curved surfaces, the angle between the electric field and area element is 90 degree. Now for curved Gaussian surface, the flux will be E dot area, and this is equal to E dA cos 90, and the value is equal to 0. So we find out that here the flux will be contributed only because of the two plane surfaces at the two sides of this Gaussian surface. So one more thing is there. According to the Gauss law, we have electric flux is equal to 1 by epsilon naught times the charge enclosed, Q upon epsilon naught. Now this charge will be taken in the terms of the surface charge density sigma that we have already mentioned, that this is the surface charge density of this thin sheet. So we also have the formula. The current is the surface charge density is equal to charge per unit area. From here we get the charge is equal to the charge density into the area. So from here we have phi is equal to sigma A epsilon. Mark it as equation number 2. If we see, we have got the flux is equal to 2EA, and the flux according to the Gauss law is equal to sigma A by epsilon naught. So now we will equate these two equations. Equating equation 1 and 2, we have twice of EA is equal to sigma A by epsilon naught. A cancels out, and from here we get electric field is equal to sigma upon 2 epsilon naught. So this is the final expression for the electric field intensity for this infinite plane sheet of the charge.